Hello friends, it's Lekajit here, and today we're going to start a new course, that is vector calculus. It's a very important part of mathematical physics, and this course is especially designed for BSc and MSc students. And if you like the video, then hit the thumbs up button and share with your friends if you think this is helpful. So this is the first lecture. Okay, here I will introduce what is vector and vector addition and unit vectors. Okay, we're going to talk about these three topics. Just an introductory video. Okay, so next video will be added to this playlist with the name vector calculus. So if you are new to my channel, please subscribe the channel, inspire me to create new contents for you, right? So now you see, let me take you to the screen of my device so that you can see the screen, and let's start. So now let me tell you what is vector. Okay, vector calculus, this is our topic, and vector is introduced to describe those quantities which are characterized by both magnitude and direction. Okay, so for example, we have some physical quantities that to characterize them we need both magnitude and direction, right? For example, displacement. So displacement, it is a vector quantity. We need direction and magnitude both, and force, you can say, etc. So if a vector is represented by a line segment, which is directed line segment. Okay, let me suppose this is P and Q. Okay, P and Q be the line segment. It represents vector A, suppose. Okay, from P to Q. Then P is called the initial point. Okay, Q is called the terminal point, right, of the vector A, right? So here this P is initial point, this P is initial point, and this Q is called terminal point. Okay, so this is initial point, and this Q is terminal point, right? So this vector A represented by the line segment PQ, then the length of this line segment, okay, this length of this line segment will represent the magnitude of this vector A. Okay, magnitude of vector A, and magnitude of vector A denoted by simply A, or you can write modulus of vector A, right? So now you see, let me tell you very important points, few very important points. Two vectors having the same magnitude and the same direction, okay, regardless of their initial point, these two, suppose these are two vectors and having same magnitude, vectors A and B, and they are directed towards the same direction. There we have different initial points, different terminal points, but direction is same, magnitude is also same. Then vector A, here vector B, their magnitudes are equal. Then these two vectors are in the same direction, then they are said to be equal vectors, right? And point number two, that vector A having direction, a vector having direction opposite to given vector A, but having the same magnitude. Okay, so we have a vector, suppose, which is in the opposite direction of a given vector A, but having the same magnitude, is denoted by minus vector A. So negative of vector A, you can say. So it is called negative of vector A. So this is now you see, this vector opposite to vector A having same magnitude, okay, this is called negative of vector A, negative vector of A. So now these two vectors, these are opposite in direction, and magnitude of these two are equal. If this is vector A, then this is negative of vector A. So hope you have understood this thing. So now let us discuss about vector addition. Okay, so let us discuss about vector addition. So now we have two vectors. Suppose this is vector A and this is vector B, right? So this is initial point of A, and this here you can see this is the initial point of vector A, and this is the final vector terminal point of vector A, and here is the initial point of vector B, and this is terminal point of vector B. So to add, we can apply two laws. One is triangular and another is parallelogram law of vector addition. So, and before that, let me tell you, we can, you see, let me tell you about parallel shifting. We can shift these vectors to join with each other parallelly. Okay, that means without changing the direction, we can join. We can shift the vector. Suppose we have a vector here. This is a vector. You can move this vector to any place in this plane, to any position of this plane without changing the direction. Okay, so there will be no issue, and that is called parallel shifting, right? So here you see, so we will join these two vectors in order to add, we will join these two vectors such that we're gonna shift this vector B in such a way that the terminal point join to the initial point of vector B, right? So terminal point of vector terminal point of vector E, you can see here, this is the terminal point of vector E joined with the initial point of vector B. This is vector B and this is vector A, right? So that means we have taken these two vectors in the same order. Okay, we have taken these two vectors in the same order. Then if you consider these two sides of a triangle, then the third side of this triangle taken in opposite order. That means, you see, we have taken vector A and B in this order, and we are taking this side in opposite order, right? In opposite order. So in that case, then this third side will represent the resultant vector of these two vector addition, vector A plus vector B, right? So this third side of the vector taken in opposite order will represent resultant vector of vector A plus vector B. So this is the triangular law of vector addition, right? So now you see, so let me explain again these things. Suppose you are to add these two vectors. This is vector A, and you have another vector, suppose vector B, okay, in this direction. So what we're going to do, we're going to join these two vectors by parallel shifting in such a way that we're going to join this terminal point of vector A to the initial point of vector B in this way. And if you assume that these two are two adjacent sides of a triangle, then the third side of this triangle taken in opposite order, we have taken the vector A and B in this order, you can see. So if you take in opposite order, this third side of this vector triangle, third side of the triangle will represent will give the resultant vector of vector A plus vector E, vector B. So hope you have understood. This is the triangular law of vector addition. Now let us discuss about parallelogram law of vector addition. Okay, again let us assume we have these two vectors, vectors B, vectors A, right? So now to apply the parallelogram law, let us shift these vectors and join their initial points. We have joined their initial points. We can join them this way also. So by parallel shifting, that this vector is shifted to this direction parallelly, vector A, and vector B is shifted in this direction, so that we can join these vectors in this manner. So we have joined the initial point of vector A to the initial point of vector B. So if you consider these two are adjacent sides of a parallelogram, so let me complete the parallelogram by dotted lines, green dotted lines. So then the diagonal of this vector in this direction will give the sum of these two vectors, vectors addition A plus vector B. So that's gonna be the resultant vector, okay, diagonal of the parallelogram. Okay, this is parallelogram law of vector addition, right? So hope you have understood this. Now let us discuss about rectangular unit vector. Okay, rectangular unit vector. So here you see I cap, j cap, k cap. So what are those? So an important set of unit vectors, okay, denoted by I cap, j cap, k cap, are those represent respectively along the positive x, y, and z direction, z axis of a 3D rectangular coordinate system, right? So here you see we have taken x, y, z axis, so mutually perpendicular. This is O, the origin is O here, so we have taken the origin O, and this is x, y, z respectively. So along x-axis, the this direction along x-axis will be represented by the unit vector I cap. Okay, it's unit vector because its magnitude is 1, and along y-axis that will be represented by j cap. So along z-axis k cap, right? These are unit vectors, their magnitude 1, and they respectively represents x, y, and z direction. Okay, so magnitude of these three vectors is equal to 1. So that's why unit vector. Now you see, take your right hand, and if you curl the fingers other than the right hand side, thumb, if you ignore the thumb, and if you curl other fingers from x to z along xy plane, in xy plane, from x to y, not x to z, if you curl these fingers of your hands from x to y, then this thumb will give the z direction. So hope you have understood. Now what do you mean by unit vector of a vector? So unit vector of a vector, given vector a, is given by vector a, it is represented by a cap. Okay, unit vector of vector a will be represented by a cap, and it is given by vector a divided by magnitude of vector a. Or you can write this way also, because magnitude is simply can be written as vector just only a, right, without giving the vector symbol, arrows head on the letter that represents the vector. Okay, so here you see, so this is vector a. It's how to find the magnitude of this vector a, right? So let us assume that initial point of a vector, we have assumed such that we have assumed a vector, its initial point is suppose the origin of a rectangular coordinate system, right? In a coordinate system, its terminal point be, its coordinate be x, y, and z. Okay, so let me draw this. This is our rectangular coordinate system. This is the origin here, x, y, z. So origin, we have taken the initial point. So here you see, so we have taken a vector, and its initial point is taken to be origin of this vector, origin of this coordinate system. This is x direction, y, and z, right? So we have taken this origin, this point is 0, 0, 0 as initial point of this vector, and the terminal point is taken as this is the terminal point x, y, z. This is the coordinate of the terminal point. Then this vector a is represented by x I cap, y j cap, plus z k cap, right? So this is the representation of vector. How do we represent in a 3D coordinate system, right? So then you see, magnitude of this vector a will be given by root over x square plus y square plus z square. That's what we will get. That's how we will get the magnitude of this vector. So hope you have understood this. Now what will be the how to calculate this unit vector? So I have already told you that unit vector of this vector a cap is given by vector a divided by magnitude of vector a. That means you can get this way, x I cap plus y j cap plus z k cap divided by root over x square plus y square plus z square. This is going to give you the magnitude of unit vector, right? And if you find the magnitude of unit vector, then you are going to get always 1, right? So hope you have understood this. So in the next video we are going to discuss about polar coordinates, and we are going to also discuss about dot products, vector dot products, and we will discuss some properties of vectors under rotation of coordinate axis. Okay, if you rotate the coordinate axis, so what will be the change in the vector and in its dot product, okay, in the dot product of two vectors. So we are going to discuss those things in the next video. This was just an introductory video of what is vector and how to add vectors, triangular law and parallelogram law. We have discussed those very basic things that you have already got in senior secondary level, and how to calculate the unit vectors, that those things we have only discussed here. So these are the topics that you have already studied early in the earlier classes in senior secondary level before you come to graduation, right? So next topic will be discussed how to represent coordinate of a point in polar form, xyz in polar form. And after that we're going to discuss the rotation of axis. What happen if we rotate the axis? This is x, suppose this is x dash and this is y dash. So we have rotated this axis, right, and about z axis. That means we have we haven't changed the z axis, and just we have rotated this system about the z axis. Then what will happen? We're going to see that what will be the change in the coordinates of this point, and what will be the change in this vector, magnitude of this vector, and it will be changed or not changed, and what will happen to vector dot products. Is vector dot product variant or invariant under rotation? Those things we're gonna discuss in the next video. So hope you have enjoyed this video, and if you have enjoyed this video, please share with your friends, and if you have understood and if you think this is helpful, then please hit the thumbs up button and share with your friends and inspire me to create new videos. Okay, if you are new to my channel, subscribe the channel. When you subscribe, when you leave comments in the comment box, then those things inspire us to create new contents. So hope and if you have enjoyed, please let me know in the comment box. Comment box is yours. You can just go and type and you write your opinion, or if I need to improve in any part of in any corner, so just tell me. Okay, so that in the next video I can improve. Okay, so thank you for watching. See you in the next video.